so let's start by the set types. So set types are iterables, are like one of the collection types. Okay. Now the set is similar to the concept of the set in discrete math. I don't know if you studied it yet. You take discrete math already or not? Not yet. Eventually you will. There is a concept of a set. So that set is just a group of values that are distinct. So you can see here why it needs to be hashable. It needs to be, first of all, it needs to be comparable. Okay? Because you cannot have duplicate values within a set. Okay? So they have to be distinct. And in order to facilitate the distinction, we need it to be hashable. Okay? Now, why do we need to put a collection of values in a set? There are so many applications for that. One of them is that if you want to eliminate duplications, so we have a set of values and you want to eliminate duplications, just loop over them and add them one by one to a set. If it existed already, it will be ignored. If it didn't exist, then it will be added without you having to check. Okay? Now you can apply all the set operations like the intersection, the union, and the difference. Okay, so intersection between two sets. What is the intersection between two sets? Usually, may have already encountered it, even maybe in high school or something. So you didn't learn about something like this. We put some values within curly brackets. So let's say 3, 2, 1. Is it familiar to you? Yeah, and then we have another, so this is set 1, and we have another set with, say, 2, 5, 3. All right, so what is the intersection between S1 and S2? You familiar with this? Yeah, intersection. So what is the intersection between S1 and S2? Yes? 2 and 3, yeah. 2 and 3. What is the difference between, so what is S2 minus S1? So that's the difference. So that means every element that exists in S2, but not in S1. What is the result here? This in S2, not in S1. So that's just 5, right? Now that's not the same as S1 difference S2, right? What is it? S1 minus S2 is everything that exists in S1, not in S2. Right? So that would be 1. Yeah. So you did learn about sets somehow, maybe not in a course that's called discrete math, but somehow you did. Okay, so this data type supports the concept of a set that we learn about in math and all the operations that apply. Union, I mean the union is just all the elements of both sets, the intersection, the difference, and so on. Now the set, the concept of a set in math is it's a collection of numbers that are unordered. Okay, so even they appear in some order, just like appearance of it, appear in some order, the order is not meaningful, doesn't mean anything. Okay, so let's try some sets here. So let me say set 1 equal ABC. All right, and XYZ. Okay, so if I try to print set 1, it may appear that it was stored in the order that I entered, but this is not necessarily true. It just appears like it. You don't even rely on the location that you entered. So when you are building a list, the order that you enter the elements have some meaning because that's how we access it with an index, right? Now here, this order even though it appears it was maintained, it's not reliable, and do not rely on it. Doesn't mean anything. Okay, so let me just try to add some other sets. So let me have set1.add. So I'm gonna add let's say number 5. Okay, now if I try set1, now it just happened to put it to be in the end. It's not necessarily happening. Now, I mean, the order that you're gonna see on my in my Python may be different than the order that you see when you run it in another interpreter, like inside Anaconda. It might be different if you run it on a Python running on a Mac. Okay, so there is no relevance of the order at all. Okay, what if I have another set? Let me have set2, like the example here, that has some numbers. So I'm gonna try to mess up the order. So let me just put this 10, 7, 0, 20. Okay. Now see, it's not even the order that I entered. Okay. Now I can append the elements that I have to another set. So I can join 2 sets. Okay. Let me just append. Let me add. I mean, the function append is not defined as part of the set, but the equivalent of it is the add. It's just they changed the name because append may give you the impression that it goes at the end. And that's what happened with the sequences. With a list and with a tuple, the element you enter goes the end. So that's why append is meaningful there. So they changed the word append to add because it doesn't not necessarily go to the end. So let me put just a number 5 so that we see what happens when we try to join the 2 sets. So now I have set1 that looks like this, set2 that looks like this. Okay, now I can say s1.update and I send it s2. So this is not gonna add another set inside the set, it's not gonna add a subset. It will take all the elements from S2 and include them or add them to S1. Not defined. Oh, sorry, set1. Okay, so now if I say set1, now see, 5 is only appearing once, even though both set1 and set2 has the element 5. But the joined set cannot have duplicate elements, so it would be added once to the joined set. Okay. Now we see the order is messed up again here. Okay, so you should never rely on an order, even if it appears like it. If sometimes accidentally it appears like it's in alphabetical order, but this is not necessarily the case. Okay, now what if I want to add a list inside the set? Would I be able to do that? So if I say set1.add a list, let's say 4, 3, 7. Do you think this is gonna go? What do you think? So what is the condition of the elements inside the set? They have to be hashable. And in order to be hashable, they have to be immutable. So what happens if I try to add a list? It will not allow me. It will give me an error saying that this is unhashable. We cannot put it in the set, even though the set itself is mutable. Okay, so the set itself is mutable, but all the elements must be immutable. Yes.
Are the things in the set being ordered by value?
I can't say yes. No, I cannot say yes. There is no meaning of order at all. Okay. Now, what if I want to add these sequence or this set of items inside the set. Yes? Yeah, I have to turn it into a tuple. So I can, if it's already a long list that was constructed programmatically, so I can use the constructor of the tuple and set it into list, so it will turn it into a tuple, and misspelled it. And then when I print the set, I will see that it is added. Yes.
What makes the list?
What makes the list? So it is the nature, there is some programmatic answer to that, but let's say it is the way that it was defined. It doesn't have a function called __ hash that generates that identity. But in order to, I can't give you an accurate answer unless it is lengthy. So we can just say it is how it is defined to be immutable in Python. Yes.
Similar to what you said about union difference, is there any way you could write a code to figure out if two sets have, like, what same elements are in two sets?
Yes, so you can call the intersection.
So is that
So let's say set1 dot intersection set2. So I'll give you the intersection between two.
oh, set one got updated?
No, it's not updated. Oh, like in the back, like we put set2 inside set1, so that's why the entire set came in. All right. Now, what if I want to put a subset? So I want to say set1 dot update. Well, conceptually, in mathematics, you can have a subset inside a set, right? So one of the elements of the set can be a set in itself. Mathematically, it is possible. Conceptually, it should be possible. Okay. Now, programmatically in Python, if I try to add a set inside a set like this, do you think it's going to go through? What is the criteria? What is the criteria? All the elements inside the set must be hashable. But the set itself, the set object itself is mutable. Now you can see we've been updating it. It is mutable. So the set itself is unhashable. So if I try to put a set inside a set, oh no, sorry. So this update takes the individual elements. I meant to add it as one element by itself. So you see what I did here? The update just takes the elements inside of the set and one by one add them. Okay, I want to add one element that is a set. It's just like I added a tuple here. So I need to use the function add. So this is one element. So if it's not hashable, it will give me an error saying that I cannot put this element inside the set. The set itself is hashable. Every element inside of it, the set itself is unhashable because it's mutable. Every element in it must be hashable, so must be immutable. Now, what if I need to put a set inside a set? I need to turn it into the immutable version of it. Just like this, the tuple is an immutable version of the list. There is an immutable version of the set. So once I'm done building the set and I want to hash it, I want to be able to hash it, I need to turn it into a frozen set. Okay, so there is another type called frozen set that I can turn my set into it. And in that case, I can add it. You see, it didn't give me an error. So if I try to print it, I will see that it is frozen set. Now, it didn't say just use the curly brackets because the curly brackets may indicate that it is a set. It is a frozen set. Okay,